don't know. Would you mind if I sat there? Because I have to move the camera for Lauren. She wants me to like move it while she writes.
Yeah.
Unless you want to do that, but I doubt you do.
I can move it
If you want. But if you want, you can like, I don't care, but, yeah, she said that, like, when we videotape, she can't see most of the board, so we have to just, like, zoom in when she's writing, and then, like, if she moves to the other board, we have to switch it. But she usually just stares to the TV, so if it's just, like, zoomed in on the TV, then that's fine, but if she, like, writes something, we have to.
I can move it.
Okay, thank you.
Who else is missing? Is he not here today?
No, he's here.
Oh, yes.
Hannah, I'm missing Hannah too.
Oh, yeah.
She's here.
She's here too.
Yeah. Is that class still going on?
They might not have heard the bell.
That's why I was just changing my clock, because the old bells were like 2 minutes off from like real time, like computer time. So they must have fixed it. So the new bells are like actually with computer time, so it's 2 minutes different than it used to be, so I changed the clock, but
It was really tiny.
The little tiny dot next to this one. Oh, okay. Let's say that big one isn't Pluto.
No, that's
actually bigger than
Yeah, but Pluto's a dwarf planet, so that's why it's so small.
It's also not technically a planet anymore.
Yeah, a dwarf planet.
it's called a dwarf thing.
Yeah,
It's still planets, just not part of our
yeah.
string of planets that are
Well, it
special.
still is
Like it's like
a dwarf. There's more dwarf planets than Pluto. Like that you probably don't. I don't know their names. So like it's not a planet now. It's a dwarf.
Do we have like other dwarf planets that are like in our? Oh,
Okay, go ahead and get out your notes. This section is really short.
It's the weirdest thing I've ever heard.
We'll just have to play it by
It's like
ear. So sometimes we need a line called an auxiliary line in order to prove things. You aren't going to have to actually draw auxiliary lines or do any proofs actually in this section. But in their explanations of the proofs in your book, they used auxiliary lines to prove things. So just so you know what that is, it's a line that's added to the figure in order to prove a theorem. So it may not have been a line that was originally given to you, and you may not actually like need it directly, but indirectly we need it to prove something. So again, you won't have to do that in this section. Possibly later on in the book we might have to use them, but just so you know what they were doing if you go to look at the proofs in your book for theorems 3.5 and 3.6. 3.5 says through a point outside a line there's exactly one parallel that can be drawn to the line. So if you have line L, let's say, and point A, so if you're given L and A, then we would say, or we would be proving your if L and A, then there's one line that is parallel to L through A. So there's only one line that can be drawn through A that is going to be parallel to L. There's no other lines that we can draw through point A that would be parallel to L. There's only one possibility. And the same is true for perpendicular lines, which is what they're talking about in 3.6. Through a point outside a line, exactly one perpendicular can be drawn to that line. So again, if we have, I guess we'll use different letters. If we have M and B, so you'd be given line M and point B. Oh, it's like 13. Then you would be saying that there is one line perpendicular to M through B. So there's only one line that will go through point B that will be perpendicular to M. There's no other way we could draw a line that would be perpendicular to M and go through point B. Okay, so this is a lot of true false today. I don't like true false personally, but you know, we won't spend a lot of time on this. So if you turn in your book to page 94, go through the oral exercises, and then you should probably have time to finish your assignment during class. Okay, so on page 94, classify each statement as true or as false. Number 1 through a point outside a line, there is exactly one line parallel to the given line. Okay? True. Good. They would have to be in the same plane. They don't necessarily designate that, but we're going to say true. Number 2, through a point outside a plane, there is exactly one line parallel to the given plane. Morgan?
False.
That would be false. You are right. Because we could draw more than one line that would be parallel to a plane. Number 3, through a point outside a line, there is exactly one line perpendicular to the given line. Yeah?
True.
True. What theorem tells us that? Theorem 3.6, I just wrote down. Number 4, through a point outside a line, there is exactly one line skew to the given line. Aaron?
True.
That one is actually going to be false. There's a lot of different lines that could be skew. And again, they don't really say if it's in the same plane or not. Obviously, if it's in the same plane, there can't be any lines skew, because in order for them to be skew lines, they have to be in different planes. But if you have different planes, what is it, one point and one line? Through a point outside a line, there's exactly one skew. So here's a line, here, over on this side, there's a point. Any line that goes through this line, or goes through that point, would be skew to the line on the front side of the box. I don't know if you can tell from my picture, but, so that would be false. Number 5, through a point on a line, there's exactly one line perpendicular to the given line. Anna?
False.
False? Why do you say false?
True. Why do I say true, or why did I say false?
Well, why did you say false?
Because I thought that, like, with one line you can make multiple perpendicular lines, but there's only one point. You can make one.
Right, so what's the difference between 5 and 3? Mac?
The point is on the line.
Yes, right. So in 3 the point is not on the line, and 5 the point is on the line, but even if the point is on the line, there's only one line that could be perpendicular to it. So here's a line, in this case the point is directly on the line, so that's not theorem 3.6, but there's still only one line that can be perpendicular to this line. There's no other way I could draw it that would make it so it would be perpendicular. And number 6, through a point outside a plane, there's exactly one line perpendicular to the given plane. Aaron?
True.
That is true, yes. Good. Questions about 1 through 6? Okay, and then in 7 through 10, we're going to say how many lines could be drawn. So, number 7, how many lines could be drawn through A that are perpendicular to line BC? Mac? 1. Right. What theorem tells us that? Mac? Theorem 3.6. Good. Number 8, how many lines can be drawn through point B that are parallel to AC? Wolfie?
1.
1 also, yes. What theorem?
3, 5.
Good. Number 9, how many lines can be drawn through X that are perpendicular to line AB? Kyla?
1.
1, yes, again, and that would be theorem
3/6.
3/6. How many lines, number 10, can be drawn through point C that are parallel to AB? Morgan?
1.
1. And what theorem would that be?
3/5.
3/5. So you get the picture. It would all be 1. Mac?
How, for number 9, how is it theorem 3/6 if X is on the line? The theorem
Oh,
is-
you're right. That wouldn't be 3/6, but it is still 1. You're right. Other questions? Good question. I don't know that we have maybe the definition of, I might have to look into that. To give you a reason. Perpendicular lines. I'd probably say the definition of perpendicular lines. You might have to go a roundabout way to actually prove that. There might not just be one reason. Okay. Other questions? Alright, so your assignment then is on pages 94 and 95, 1 through 15 odd. Like I said, you should probably be able to finish that in class today and maybe check with somebody, and then we can move on to the next section tomorrow. 94 to 95.
Did you say you wanted to do 15 off?
1 through 15 odd.
Wait 1 second.